you. Welcome all. This is the ARM AArch64 BoF. I'm just going to start us off, do some embarrassing congratulations because nobody in my team, well, everybody in my team was too modest to do that. So I was like, I am not. I am more than happy to brag about people in our community and congratulate them. So I'll go through the agenda, I'll do the embarrassing congratulations, and then I'll walk away. So today, hopefully we'll go, it looks like a lot, but we'll go through them. It's not a lot of content as such, and there'll be enough time for Q&A as well. But we'll start off with talking about the newish maintainer landscape for AArch64. We'll talk about some updates that we've talked about last year, so following up on some of the topics we discussed, and Wilco will do that section. We'll look at the roadmap that we have for GCC 16 and beyond because we never know when they actually get committed. So there are some topics that will be covered by Wilco, Tejas, Alfie, and Tamar. And then we'll have some open topics that are not yet on our roadmap as such. Some of those because we just don't know. Some of those because they're still in planning phase. And then we'll have some feedback requests for some of the recent works we've done, and we'll open for questions after. Okay, so first of all, I would like to thank Richard Sandiford for all of the effort and his superhuman ability to post reviews for the AArch64 port. So a big thank you. And then, I mean, obviously I cannot state it enough how much contributions he's made, both with the patches as well as the reviews. But then I would like to. Are you speaking in the past? Sorry?
He retired.
Oh, okay. Okay, not that bad of a news. Yes, he's just retired from the AArch64 port. I think he's still around in the community a bit, but in the AArch64 landscape, he's handed over to a few new people in the community. So we have Tamar here, who's where did he go? There, who's our new AArch64 maintainer. And then we have Alice Carlotti, Wilco, Alex, and Andrew Pinsky here, who are our new reviewers for AArch64 port. So big congratulations to all of them, and thank you for all of your contributions. And you have very, very big shoes to fill and a lot of work cut out for you. But moving on from the GCC AArch64 port, I would also like to congratulate our machine maintainers in glibc, in Wilco and Yuri. Yuri couldn't join us, but Wilco is here. And then finally, in bin utils as well, we have a new AArch64 maintainer in Alice Carlotti. So I just wanted to embarrass a few people here, and now I'll hand it over to Wilco for some other topics.
Is ARM32 dead?
Oh, no. I mean...
ARM remains committed to the future of AArch32. However, as many new architecture features are only coming out on AArch64, that is our focus at the moment.
Yeah. Yes. That's fair.
I was clickbaiting.
Is there a need to look at just because the question came up, is there a need to look at the primary and secondary targets with respect to AArch32? We don't need an answer here, but it may be something to think about.
Fair enough. I mean, we're still committed to the port. It's not like, it's just as the features come in or not. Fair enough. That's a fair comment.
I still remain one of the AArch32 members.
Yes. Yeah.
Okay, so some updates from last year to start with. Atomics, we've been discussing that for some time, including last year. I had some slides on it. We did do quite a lot of work on it, and so far no complaints, so it's all worked out. So there have been some new features being added in GCC 15, so LR CPC3. And recently, we created a document for the Atomics ABI that's been published. It's still in alpha state, but we keep adding stuff to it and adding more instructions to it. As you can see, the recent one was LDFAT. There's also a bug report about sorting out the layout of _atomic. So there's a structure that you can create in C, and you can, for example, create a 3-byte structure, and then it will use locks. And so the idea is to increase the alignment to 4 bytes, and then use non-locking sequences, so real atomics on it, as I presume was the intention. And the result of that is, if you do that for all of the sizes up to 16, then you don't need lip atomic, and all sizes until that size are then lock-free. And that's the kind of thing that most people seem to want. There's future work going on, so there's a few new instructions that are hints for stores that people are looking at the moment. And there's another one called LSFE. And then outline atomics, we don't really have a solution for that right now, but one idea is to either inline it and avoid the extra call that, again, people don't like as an extra library call, and it can cause problems in some cases. The other option is, of course, if distros use a slightly higher architecture version, then you don't ever need to worry about those cases. So then LSE would be the default. And finally, so that's the same kind of thing as what the Atomics ABI tries to achieve, to avoid most cases to call lip atomic, so you don't have to include it and you don't have to worry about locks and other stuff.
So, do you happen to know? Okay, so do you happen to know whether A, Apple has defined such an ABI, and B, whether the ABI that we're talking for GCC is going to be compatible or not? I mean, there are differences between AAPCS and the Darwin PCS, I know, because I'm doing the implementation. So anytime we come across something like this, a heads up on whether we're likely to end up with a trouble is useful.
I am not entirely sure what Apple would do in this case, but we do know what LLVM does. And LLVM does effectively what I'm proposing here, so it over-aligns.
It's likely to be the same.
So then it's unlikely that others
that
use
use good.
LLVM use the same. So
That's likely to be the same then.
okay, more questions? We don't know.
I just wanted to ask, are you blocked on anything? Is there anything you need from the community or reviewers in particular, or is everything proceeding steadily?
Basically, I've posted a proposal for that particular thing in the Atomics ABI specification. It's public, people can comment on it. I think there's a link in it as well. There's 2 links, one to the bug report and one to the Atomics document. So anyone who's interested in this can contribute to it.
Question, I should probably go read this, but is the Atomics ABI part of the base ABI, or is it platform specific?
Oof, that's a good question. The idea is that it would apply to anything in principle, because the atomics are fairly generic.
So if it is going to be generic and that's the thing, then maybe I think you want to think about whether this is base ABI that applies to all implementations or whether the platforms have a choice. In GCC and LLVM on Linux, we may well choose to make this as the default, but it may be good to check that particular concept.
Yeah, I mean, you can always have your own sort of slight differences on the API, right? So we know Microsoft has a slight difference from the standard API documents. And
does this mean we need a flag day or something where compatibility changes?
For this particular case, this particular API already changed, interestingly, a few, 8 or 10 years ago, but only for sizes that are exactly a power of 2 already. So if you have like an atomic struct of 4 bytes, but 4 chars, then it normally would have alignment 1, but in GCC, at some point, the change was made to make it alignment 4. It's exactly the same change, but only for a subset. And I think that was done just with a warning if you use that.
So this was the GCC 15 change that Alan Lawrence did for the over-aligned types that ended up applying for 5. Sorry, 5?
It was a while ago. I forgot
5.
exactly what version it was, but there was a version that changed it.
5, yes. Yeah, I'm thinking 2015 and confusing it with.
I did the code search just to be sure how often these structures are being used, and the only use I could find is ones that actually are power of 2 already. So people are already using them, but only in cases where you just have an int in them, or a long or something. So I've not seen any case where people use like 3 chars, except maybe for test cases, but I don't count those. Okay. Vector math. So basically, there's been a lot of work on libmvec. People have been writing lots of math functions and optimizing some existing ones. So as I'm stating here, there's about 140 different functions now, both for SIMD and SVE. The performance has improved a bit as well. If you compare with the very latest glibc and the very latest GCC, then on the right you see the graph with the improvements. Especially impressed with the WRF improvement of more than 10% now, so that looks quite good. It could actually even be better, because I think iMagic over there does not seem to gain anything, while last year I showed a graph with about 5%. So hopefully we can get that as well. But we will see when that happens. A recent change that was done was support for SVE math calls. Previously, that wasn't working, and there was an issue with predicates, if I remember. That's now fixed, so they're now fully supported. In the future, one thing we are thinking of is unrolled libmvec calls and hoping basically to improve that graph further. Basically, if you can make use of wider vectors, but you don't have really super wide vectors, you can actually have a math call that deals with 2 or maybe even 4 vectors at the same time. And that means all the overheads are, making the call and computing the polynomials is then spread over multiple vectors rather than over just one. And hopefully one of the things that is still unresolved is the SIMCOS interface, which is effectively related to this, which also wants to effectively have multiple inputs and multiple outputs. The only sort of difficulty with that one is, I think for SIMD you can easily do it, but for SVE it might require an open MP extension, because there's no sort of easy way to do it. There's a bug report on Fortran. Effectively, what Fortran does is it doesn't really check the vector math and whether it's fast math or not. It literally, if there's a vector math function, even with O2, it will just use it, whether you like it or not. And the vector math functions are basically written for OFast, so that's because they have a slightly lower accuracy. They don't care about exceptions and other things. Sign zeros, you name it, not the numbers. They don't really treat those always perfectly. And so it's not a good idea to enable this even in O2 and potentially get the wrong math results. So I've made a proposal to add an additional if statement at the end. So if you look, this is basically a line from the header. So that's how you write it, it's a magic syntax. And if you add that thingy at the end, then the compiler will know that you only want that particular thing if you're already using fast math. And the nice thing about it is if you use this header on an older GCC, it won't give you an error. It will literally just ignore that particular math function in all cases. So it's kind of backwards compatible in the sense that the bug goes away in all the compilers. So in that sense, I like the idea, but I would like to get some feedback on it if possible. This is a slide from Alex. He couldn't be here, but basically he's been working on LDP paths and do fusion of multiple loads into LDP. In GCC 15, there was a lot of work to make the paths independent. with some others. There is some idea that potentially it could be used in FEM2, but so far no one has been started to work on that. Some of the future work, there's a few outstanding potential improvements. So you could remove some of the existing peepholes by making the LDP paths handle all of those cases. So there's several cases of that. So one is, I think it's like four loads and stores. I think that's mentioned at the end. So if you have 4 loads and stores, then you could potentially emit an add and 2 LDP instructions. And then that way you can use more LDPs again. What else was there? Yeah, there were some minor things related to how it can analyze the load stores in RTL and get the right alias info. I think Alex is looking at that and see whether we can further improve that. There was some very simple fix for at least one of these cases, as mentioned there, where you just need to switch the alias analysis on in the RTL basically before the path starts. But then there was some regressions as well, so we'll need to look at that. I think that's pretty much it. So there's a few more sort of smaller improvements. And then there's a roadmap for GC16 and beyond. So one very recent patch that went in, or improvement that went in, is compare and branch support. Basically, it's a new AMV 9.6 instruction that combines compare and branch in a fairly general way. So you can do register with an immediate and register with register comparisons, and also have a branch. The main goal of this is code size reduction. As you can see on the right, a few simple cases where you just need a single instruction to do a compare with a register and an immediate and branch at the same time. So my original goal was about 3% code size reduction. We're achieving at the moment about 2.5%, thanks to Richard Henderson, who fixed some bugs in the original commit. But unfortunately, it has to switch off some cases. So it means that we could potentially do better, but we don't quite get there yet. So some of the future work will be to improve the current set of patches. On the right, we see a case where if the branch destination happens to be out of range, then currently what it will do is it will emit the single instruction branch followed by a direct branch to the far label. And then obviously you have 2 branches. Well, if you did at this point, you change that back into a compare and a conditional branch, it would be a single branch. There's some complexities with that, but so we're looking into doing that. There's also potential to improve switch statements using these instructions by making sure that the switch expansion code understands these instructions and the costs of these. So for example, you could use one of these instructions for each switch label. So case 1, 2, 3, 4, etc. You can just use a single instruction for that. Okay. And here's a graph with the current results that we're getting on Spec 2017. So basically, most of the cases are, around 2% or more. But there's a few cases that get about 7%. So that's quite reasonable results. Okay, next.
Hit that.
Yep.
So this work started off as me trying to introduce Boolean vector extensions, GNU extensions, and then after some discussions, quickly realizing that I'd opened a can of worms, so closed that can and just fell back to SVBool because of the issues that we just discussed in the vectorizer BoF. So pretty bog standard bool type, ACL, it's an SV ACLE type. Currently, all the number of operators that are supported are those listed there. Index operator is a bit tricky, but it's getting there. Last year, the other SV types were supported for all the C++ operators natively.
That's it.
Okay, similarly quickly, as mentioned in my other talk, the function multi-versioning was added in beta for GC15 and fully for GC16, with some work continuing for sort of C support and some extra architecture ticks and such. And then we have the 9.6 2020 and 2024 architecture release roadmap. Currently, the ATLE intrinsics are being defined again openly on GitHub. So if anyone has feedback, please take a look. They're being worked out at the moment. With I think the majority of the assembly and disassembly support landed in bin utils 2.45, and we have intrinsic support sort of targeting GC. Some hopefully to get in 16, but the majority will end up in 17 for most of these features. And then I'll hand over to Tamar.
So, hello again. So some bookkeeping first, so our planned releases. So we'll have a release around November for GC 15.2. And then next year around June, we'll have for 15.3. Pretty standard cadence for us. So bookkeeping done. Now it's time to talk about what we're going to do next, about the new architecture features. However, unfortunately, Cauldron is early this year, and the embargo expires somewhere time next week. So what can we talk about? About a year and a half ago, Microsoft started working on supporting GCC on Windows. At the moment, we have transitioned this work now into ARM. So we'll be doing this work as part of the toolchain team, and the wider ecosystem enablement is being done by a different team in ARM. But our goal is to have native GCC on Windows, which is as much parity as we can on x86. And then we'll see if we can fix some of the issues with Windows support for GCC. We're trying to ramp up work again on GDB. So we've started ramping up expertise in the team, getting it up to speed again with the goal to help Linaro out here as well, and to start adding some of the new features that we needed. The first thing out here is Yuri posted a patch, I think 2 weeks ago, to finally be able to support debugging of predicates in GDB. So you don't have to interpret these magical bits that don't make sense. So I'm personally looking forward to that. We also plan to try to break away the Python version dependency from GDB, because it's been causing us quite a lot of pain to package. At the moment, it requires GDB on Python 2, and moving to Python 3 and having a fixed version again was difficult. So we're trying to abstract away from that native Python interface into something higher level that we can work on. So for the plans for what we did last year, two big things are FP8 and FPMR. I'll come back to these later on today. And SV predicate variable printing, so that's the work that Yuri is doing. Plans for 2026, we want to enable SME without SVE support in the compiler. At the moment today, we'll tell you how we don't support this. And yeah, that was pretty much it. So topics not yet on our roadmap, but that we're considering. So LLVM has added the flag MSV vector bits, which is analogous to MSVE vector bits, in order to allow it to give a fixed size vector to SME vector, analogous to SV ones. We don't really know if it's useful, so we're kind of debating whether we want to support this or not. But yeah, if anyone has any feedback on that, the SVE case was a bit more clear. The SME one, I'm not really sure what you would use this for. We're considering making an addition to the ABI to allow for tools to better be able to reconstruct control flow from binaries. So think here about like adding marking for no return functions, so that the tool knows that there's no control flow moving back upwards. Or like if you have jump tables, so it knows that the content of of the table are addresses, and so you know where to branch from and where you branch from, etc. Now I've given two talks on this already, but once more with feelings. So ARM introduced this HVLA, this hybrid vector length agnostic mode. Now if you see the first slide, classic neon, you have a vector that consists of 128 bits. You have SVE that consists of vector of different element sizes of no known size. And now we have HVLA, which consists of a variable length vector, which consists of 128-bit chunks. And the idea is that if you can use them to vectorize advanced SIMD instructions to a VLA context. So that every iteration is doing a multiple of 128-bit elements at a time. And the reason for the new instructions are that, for instance, like if you were doing reductions, for instance, in your loop, if every loop iteration you were reducing the 128-bit chunks and storing it into a memory address, your reductions need to be done in these fixed chunks as well, for instance. Or if you're permuting the values, you can't permute them into different vectors. You must permute within the subcategory, etc. So that's why there are new instructions, or why we can't just reuse normal SVE for this transformation. We're also looking at the CPA, checkpoint arithmetics. So this is an extension of MTE. And the idea here is that if, for instance, in this example, if you subtract P2 from P1, if they pointed to different objects, then the difference will be invalid. And so you would check this, you'll be able to check this at runtime instead of crashing somewhere else. This has a lot of major implications in the compiler. For one thing, it means that pointer arithmetics is no longer commutative. Your base must be the first argument and the offset must be the second one. So the compiler can no longer use plus for pointer arithmetic, it must use pointer plus expression. And so this will permeate to the entire compiler down to RTL, etc. And RTL, again, you can't use plus. You must use a fixed addressing mode. And one of the instructions, for instance, in this example, the instruction that would replace the delta, the normal minus, would be the sub PT, which tells you that it's the checked tag subtract.
So you no longer can cast to integers?
No.
To do subtraction or anything?
If you do that, then if you lose then you lose the fact that it's a pointer. So yeah.
Okay. Because one of the reasons why I ask is because even lib standard C++ casts some pointers to do the full the full comparison.
So we've done some similar work for this for the we did some similar work for this for the Cherry architecture. We know it's extremely painful, so it's going to take a while and probably a lot of discussions upstream about how to go about it. So some feedback on highlighting some work we did in the previous year. So last year we implemented support for FP8. This is a 8-bit floating point format. However, the format itself is not fixed. It's controlled by some feature bits that you can set, which controls how large the exponent and the mantissa are. So for now, we started out supporting 2 formats. So a 4-bit exponent, 3 bits mantissa, 5-bit exponent, 2 bits mantissa, and we might expand this in the future. The way you use this is you have these set instructions that you need to call to tell it what format the instructions are going to be operating in. And you pass this format to every single intrinsic call to tell it which formats its inputs and outputs are. Now, the problem with this design is that the change would have to happen between each instruction. But if no change happened, you would want to float off the changes, the changing modes. And so we added a new pass for it. So for instance, GUC generates a very nice loop, moving out the control bits outside. And we also have some feature bits if, for instance, you end up in an architecture where checking the register is quite expensive, then we can change it into always setting it. But if checking is cheaper than setting it, we can change the codegen to check the value and only change it if it's different. So we have some control bits here to help with different cores. But yeah, so we'd like to, if anyone has given this a try, if you have any feedback, cases where the code gen missed something, we would be quite happy to get that.
This passed because I fixed it up because of compile type.
Well, so the other thing we added along GCC and glibc is GCS, which is an implementation of shadow stack support. So yeah, it requires the moment you to compile your binary with mbranch protector equals GCS, and then you still choose at startup time for glibc which mode you want it to operate in. And so you have those three modes: disable, which is the default; enforced; option. I think what's the second one? Check markings but keep GCF itself off, or enable GCF regardless of markings. Again, we have no idea which ones is useful or what the overhead is on large applications, so any feedback would be useful to us. And lastly, Ramana asked a question before about where the ABIs and stuff like that are located. We wanted to highlight ARM has quite a lot of open source repositories where a lot of our discussions take place. AAR is a special one. It's just where we upload optimized routines for ARM. The licensing should make it possible for you to use it in any project that you want. We have experimental versions as well, so for SVE, MTE, stuff like that. String routines, networking, math. They're updated quite regularly, and they're quite well maintained. Usually they are committed to AAR first before they go out to Android and glibc and various other runtimes. In terms of ABI, we have our main ABI GitHub repository as well. Usually we will post pull requests for any ABI change, and it's open for discussion. So you can subscribe to the repo if you want to have feedback if you want to see any new upcoming ABI changes, give feedback. We discuss with multiple vendors there. So it's really a time where if we are about to make a change that makes it hard for you, we can listen. Next one is ACLE, again, our intrinsics, again, fully open source, same thing happens. We pull a pull request for every single thing, it's an open discussion. If it's hard to implement in your toolchain, your compiler, or whatever, let us know, and we'll see if we can change the design before it becomes final. And lastly, people ask all the time, where do you find your counters? I want to write a tool that does, for instance, looks for these particular counters on every core. We do have a machine-readable repository of PMU data. So this is quite useful if you're writing a profiler or whatever. It's often asked about requests that people don't know already exist. And lastly, just a shameless plug. I'm not that. So every single year we do write a blog post about every single thing that went in on the AArch64 port, graphs, numbers, examples. You can always find them on developer.arm.com, actually, community.arm.com. They go back all the way to GCC 10. This one in particular is a 50-minute read, so if you're having trouble falling asleep, I highly recommend it. And yeah, I think that's it. Any questions?
First is a comment that Tamar, you had very nice slides with GitHub repos in them. And the question is everything okie dokie? Do you need help with anything? Everything solved, everything implemented?
In GitHub, to be fair, I only manage AOR. The rest are different teams, so I can't tell you.
But for the, what are the issues, problems in the ARM backend?
Not exactly issues, problem. For instance, the SME ABIs required quite a lot of rework. Things we could have caught earlier if vendors had reviewed the specs early. Issues with the kernel and stuff like that. So we tried to accommodate to figure it out before we made the changes, but without extra input, there were simply things we just did not know. And so that's why I want to point it out. If we can prevent the mistake where we have to go in and change an ABI again later, it would be very helpful.
No, just a quick question. Do you know if for GCS, if distributions are planning to experiment with it or are trying it?
Good question. I do not know.
Do this.
Yeah, since you ask about MSME vector bits, I mean, I guess since we don't aim to auto-matricize C code, maybe the extra assumption of the vector width might not be super useful in code gen. But one thing that I find a lot of users of SV intrinsics forget is that when you use SV vector bits, you also actually change in slightly the language semantics, because now you have things you're allowed to put SV types into the structs and all that stuff. So maybe now, bit of complexity to consider what happens when you have like SME, streaming, I guess streaming SV context, and you have VLA types and you want to put those into structs. How does that, and what happens if you're not streaming SV code has different SV vector width? It's probably a very complex spec space to explore, but that's probably where you do need to specify some kind of SME vector width.
Yeah. So unfortunately, the change was kind of made without any good rationale. So now we're trying to make some retroactively. So yeah, if there is a good reason to do so, yes, but fixed SV vector bits have also caused a lot of issues for us in the compiler. And so it's like if there's not a very good reason. However, unlike LLVM, GC can auto-vectorize SME code. So we can auto-vectorize into streaming SME, for instance. So that's also one of the considerations that you have to take into account. So we can't, at the moment we won't do matrix multiply, but we could in theory.
You can do streaming SVE.
Yeah.
But that's just normal vectorization.
Just
normal vectorization, yeah, but it was designed to work that way.
Okay.
Like now, the streaming mode will also have the vector length will be different. So if you specify the SVE vector width, vector bits, and the SME, you have a call where the SME vector bits is different, that will be a correctness issue. Yeah.
You probably need some sanity checks between.
But it's just whether it's worth breaking out. Like, is SVE vector bits a thing that's important enough for us to do the work to split it?
I've been surprised by the number of people who are actually using it.
Yeah, but for SVE, like I said, the use case made more sense, right? Being a lot of the projects still wanted to be able to put an SVE type inside of a struct. But on the other hand, we never optimized for it, and so retroactively we have to go back and say, oh, it became a lot more popular than we wanted, than we thought. So now we have to optimize all this code around it.
Well, I mean, maybe you didn't put as much emphasis as VLA, but the support for SVE and SV vector bits in GC has kind of been designed, thanks to Richard Sanford again, to be actually that good. You get good code and out of an extra vector bits assumption almost automatically, because things where you would have added a VL now gets made into constants. The vector heuristics kind of all work out. So I find personally in our benchmark that GC does generate slightly faster code, MSV vector bits, when you do have that extra assumption with very little painless additional tuning.
Well, so where completely falls apart is if you put this into an STD container. Like if you put it into an STD array list, for instance, and the compiler does not inline it, you get a very expensive reconstruction of the vector through the stack.
Yeah, I can believe that.
So it's those kind of cases. Like, so the normal cases will work fine, but then people will stuff them into other container types, and then.
Do you recommend any static tools which gives out microarchitecture level information, like LLVM MCA, for example, so that we get to know about the latency of instructions, the throughput, based on the choices or the instructions that are getting generated, probably from assembly or from object temp or something?
Yeah, at least for GC, I don't know of an equivalent tool to LLVM MCA, unfortunately.
But you can use MCA. Yes.
Well, I was gonna say is that we don't put scheduler models anymore either, or at least we try not to. I know you guys have been adding some.
Yeah, but I mean, even when we were putting scheduling models into the actual backend, the aim there was not to have a faithful description of the CPU. It was more of to do whatever we needed to get the kind of scheduling performance we needed out of it with the minimal amount of bloat to the compiler. So unlike in LLVM, where the aim is to have as complete a model as possible so you can get the MCA experience rather than the scheduling experience in GC, where it was, even when we did have scheduling models, they were like a very rough reference for the reader.
And also, like, anytime we did add a new scheduling model, it made no difference for performance because the core was better.
Maybe that's something that we need to discuss about O2. Right now, O2 has this. You guys didn't make a mention of this for 15 at O2, the pre-RA scheduler is gone, but at O3 and OFast, it's still enabled. Is there a plan to figure out what needs to be done to disable it, or what needs to be done to fix up, such that it's not as aggressive anymore?
So I think the reason we left it on at O3 is because it's quite sensitive for stuff like FMA chains.
Right.
And there was no real alternative to get it. We couldn't really figure out a way to do the scheduling without having a scheduler. Like, we might be able to use the dispatch-based scheduler that you guys added now, but we haven't really looked into it. Where we do have a very detailed model is currently our vector cost model. But that's not used by anything other than the vectorizer.
Yeah, I was just going to make a mention of the dispatch scheduler as something new that we've been working on. And that may be something to look at because it's not a traditional, the traditional DFA style scheduler, which doesn't scale very well to big cores anymore.
It's cheaper than normal
It's exactly.
Well, on the question of what you can do to figure out what the performance of your code is, which I think is what you were getting at, is with the DFA scheduler, you could look at the schedule description and see what this instruction, what the compiler thinks its latency is. With dispatch scheduling stuff, and I think we have some debug output, but it probably could be better. But the compiler at least has information about at what point it thinks the units are full. Therefore, that might be useful insight. But like with MCA, it has a lot of big caveats around how well it represents real dynamic performance.
Yeah, so I've been kind of hacking around that you can have a new debug flag that would print next to the assembly the pipe and the window for the scheduler.
It currently does.
Does it?
-D capital. Yeah, that's
super
A.
Okay.
Yeah.
I need to take a look.
There is one. It is superimposed.
Yeah.
Okay.
I was just going to add that Tamar showed a link to a bunch of PMU schema. There are other tools which talk about top-down methodology and Linux perf. That might be interesting to look at. The other place we've found useful to look at is looking at perf output with SPE. That has been something interesting to understand more about the performance. But the traditional older style in-order thing of associating latency with specific instructions, that's much harder in today's CPUs. So there are techniques you can use, but they're not as we are used to from traditional in-order cores or traditional performance analysis tools or profiling tools that we've seen in the past.
So today it's more about branch prediction and cache misses and not so much about latencies of individual instructions. No one really cares anymore. You don't notice it when it's an extra cycle latency or not.
Yeah, throughput matters more. That's why sometimes we just emit more instructions just to get better throughput.
Yeah.
That actually might worse.
Should do. Unless it reaches a particular level that the code size is too big. And then you get into the next set of problems.
Yeah, I cache.
Yeah.
Yeah, we have large caches. We're fine.
All those logics in my phone. True. And the buffer, and the reload, rename buffers and all that stuff.
Yeah.
Right? Yeah.
Yep. Any more questions? All right.
No.
Well, thank you for your attention.
Thank you.